Let's do work at example 1. Consider the following knowledge base. Consider that we have these facts stored in the knowledge base. Vegetable aubergine and vegetable potato, vegetable tomato, meat chicken, meat beef and meat lamb. Ingredient tagine aubergine 250, ingredient tagine tomato 100, ingredients to beef 400, ingredients to potato 600. We can check the ingredients of tagine by asking this question in the query. Ingredient tagine, ingredient, and noted that the I is in capital, then amount, and the A is in capital as well. If we run this query from within the Prolog environment, we will get the following answer. The ingredient is going to be equal to aubergine and the amount is 250. We still have another ingredient because as you can see here we have tagine and tagine, and this one have the ingredient aubergine 250 and tomato 100. So these values are going to be displayed. Let's do it practically. Okay, let's open the SWI program. Then we go for the file. Of course, you're going to create a new file, but I already have this file, so let's edit it to see the content of this one. Work at example 1. Okay, these are that should be stored in the knowledge base. And let's close this one and open file, consult. Let's consult this database to work on. So we're gonna write query, and this query is gonna consult to that file. Ingredient tagine, comma, and ingredient. It doesn't have to be ingredient, by the way. You can write any capital letter or any word that starts with a capital letter, like ink. Okay, comma, and the amount. Again, it doesn't have to be the same. It doesn't have to be the same word. You can just write any letter like A. Okay, and do not forget the full stop. Then enter. So we have ingredient 1 aubergine, and the amount is 250. We have another entry in the database which is related to the ingredient. So we're gonna press a semicolon from the keyboard, and it will bring the second item, which is tomato, and 100. Okay. Now let's add some rules to the knowledge base, because the knowledge base does not contain only facts, but it contains also rules. So and these rules are working on the facts that we already stored in the knowledge base. So both of the rules and the facts should be stored in the same knowledge base. Using the knowledge base from the worked example, we want to know which dishes contain meat, and we are not interested on how much meat or the amount, so we do not need to know the value of the third argument, which is the amount. So here we need to know which dishes contain the meat. So we're going to write here contains meat as a predicate, and between the brackets we're going to put X, because we don't know exactly which dish. This will display the dish that contains meat. Colon dash, this one means if. So contains meat X if ingredient X, comma, meat, comma, underscore, which means ignore the third argument in the ingredients predicate. So the comma here means and. So if this condition and this condition. Okay, so the comma here means and. Let's write this rule into the knowledge base. So we have to open the knowledge base first by opening SWI Prolog. Then we go for the file, then edit, and example 1. Okay, so here I wrote contains meat. This is the rule that I have to write here at the end. And as you can see, we write the colon, that means colon dash means F ingredient. That means display the dish, F the ingredient, and this is the name of the dish, because the name of the dish is the first argument in the ingredient predicate, comma meat. This is another variable because we don't know if it's chicken, beef, or lamb. That's why we put here meat as a variable, comma underscore. That means we need to ignore the amount because it's not needed. So here we have the dish in the ingredient. Here we don't know exactly uh, which uh, which type of meat we're gonna present, gonna be displayed. Then comma, and the amount is not needed. Comma and this complex condition, because we have two parts in the condition here. Comma meat meat. That means the predicate meat here, and meat. Have here three types of meat, which is chicken, beef, and lamb. After, of course, after you type this one, you have to go for file and save buffer. Then we close that file. We go for the file and consult again, and we consult that file because the query we need to be operated on that file. So let's write the query, which is contains meat here, and see what it would return. Contains meat, between brackets we type x and dot, then enter. Stu, this is the first item from the database. This is the first dish from the database. Let's press semicolon to see the second item. We don't have a second item, so that means x should equal to stu. Let's have a look at the second example. Okay, here we have the second. Here we have a knowledge base that should contain these lines of effects. We have the parent Fred and the son is Jack. The parent is Fred and the son is Alia, and Fred and Paul, and Dave as a parent of Fred. So this is the parent and this is the son. We know that G is a grandparent of S if S is parent of P and P is parent of S. So that means if we have, like here in this example, Dave is a parent of Fred. Okay, and Fred is a parent of Jack. So that means Dave is the grandparent of Jack. And this is how we write it, grandparent. So that means we can write this rule in the knowledge base. At the end of the facts here, we can write one of the clauses as a rule, which is grandparent G, comma S. These are variables. If so, that means G is a grandparent of S in case G is a parent of P, and at the same time P is a parent of S. That means G is a grandparent of S. Okay, a person has a sibling, brother or sister. If they have the same parent, how can we write this rule in the knowledge base? We can write sibling A, comma B, if P is a parent of A and the same parent P is a parent of B. So A and B are siblings. If you run this query from the Prolog environment, Jack, comma X. If you run this query, sibling Jack, comma X. So what do you expect would be the result? So Jack and X. Let's see who is the parent of Jack and at the same time is the parent of X from the facts we have here. So the parent of Jack is Fred. And again, we have here the parent of Ali is Fred. So Jack and Ali are siblings. We have another entry here. Fred is the parent also of Paul. That means Jack, Alia, and Paul are siblings. Okay, let's do it practically on Prolog. So we have to create a knowledge base that contains these facts and the rules. So first of all, we open the SWI Prolog, then we go for File, New, to create the new knowledge base. But I have this one already created, so let's open it, edit, go forward with example 2, and these are the data written here. These are the facts. Parent of Jack is Fred, Alia is Fred, the parent of Paul is Fred, the parent of Fred is Dave. So grandparent GS, grandparent GSF, parent of P is G, and parent of S is P. Sibling A and P, sibling A and P, F. So A and P are siblings. F, parent of A is P, and the parent of B is P. Okay, and we have another and here, and not A equal B. To be able to figure out what does it mean, let's remove this first from the line here. Okay, we end it like this and save the buffer first. Then we can close or keep it opened. Then we go consult that file. Okay, then we write the query, which is sibling okay Jack comma X, and write this one down. So what do you expect would be X? It should be Alia and Paul, but look what will happen when we press enter here. So Jack is the brother of Jack, which is incorrect. We have to avoid this one, and I'm going to show you how to modify it in the knowledge base by modifying the rule of sibling in the knowledge base. Then press semicolon. This is correct. Press semicolon, and that's correct. So how do we modify it? We go for the file, edit, open the knowledge base, and here we have to write the following comment, which is I'm going to remove the dot and put and, put the comma, which means and, write or not A equal B, and full stop. We save the modifications we made for the rule. So we need to display all the siblings, but we don't want to display the same name again. So let's close this one after we save it. Any modifications you're gonna make for the knowledge base, and to be able to run a query again on the new modifications, you have to go and consult again. So we have to consult the file again. Okay, then we run the same command again. So Alia, this is correct, semicolon, Paul is correct, and that's it. Let's talk about the anonymous variables. We already talked about this one in the previous example. We said that if we use underscore, that means we ignore that value from the predicate. We are not interested in that value or in the predicate, and this is how we use the anonymous variable. So underscore means anonymous. The rules in the Prolog. We already talked about it in the previous example also as well. Rule in the Prolog consists of head, colon, dash, which means F, and the body, which are the conditions. As we saw in one of the previous examples here, let's go back for this one. We have the sibling A, comma P, F. The parent of A is P, and the parent of B is P. So we have here the head, which is the first part of the rule, and the second part is called the body.
Backtracking. This is the process by which we can check how Prolog arrived to the answer. Uh, as it is going to show you step by step how did it move from one predicate to the other predicate, and what was the final answer at the end. So it will show you the calls from predicate to another predicate, and the result of this call, and at the end how did it arrive to the answer. So we have two ways of performing the backtracking on Prolog. One of the ways is to use the graphical debugger, and the other way is to use the trace command. So this is how it looks like on the right side when we use the trace command, and on the left side this is how it looks like when we use the graphical debugger. Let's do it practically on Prolog. First of all, we're going to open the SWI, and then we open the knowledge base for the worked example 1, and let's go and consult this file. So whatever the query you're gonna type is gonna be implemented on that file, which is the worked example 1. Okay, now we can close this one or keep it open, doesn't matter. So let's keep it. And let's start with the first method, which is the trace command. To start this, what you're gonna do is type the word trace. Okay, now it's ready for your query to investigate. Let's write the query, which is contains meat and x. Then we press after the full stop, we press enter. So this is the first call from the Prolog to the contains meat predicate. If we press enter, this is the second call from the contains meat to ingredient, and the creep word here means the Prolog is going to move from that predicate to another one. As you can see here, the contains meat is going to call another predicate, which is ingredient, and if we press enter, we have two types of ingredients according to the dish. We have the tagine and we have the stew. We have the tagine as the dish, and we have here the ingredient, which is the aubergine. Let's press enter. Uh, Here we have the exit. That means that was a successful call. Creep again to the second part here, which is meat. So meat aubergine, because this is the ingredient written here, and this is another call for another predicate called meat. Let's press enter and see the result, which is fail. Why it's a fail? Because this is incorrect. Aubergine is not a kind of meat. As you can see here, the meat, it has to be a chicken, beef, or lamb. So let's make enter. Redo means we return it back. We made another call for the ingredient, and we press enter. Then uh, we or the Prolog is gonna move to the ingredient with the tagine and tomato, because this is the second one here. And when we press enter, it will call again the meat predicate with the tomato, and of course it will fail because meat should be, as we said, chicken, beef, or lamb. If we press enter, we made another call again. That's why it's redo for the ingredient. If we press enter, the ingredients would be stew. We'll have the two arguments, stew and beef. If we press enter, we make another call for, we made that call for the meat, beef, and we already have, yes, a meat beef. Okay, And in the ingredients, here we have the beef, so we have a meat with beef. That means that means a successful call. And when we press enter, the result would be displayed, which is the stew. Okay. So here the contains meat will equal to stew. That means x is gonna equal to stew. When we press enter, so x is stew, and that's it. Okay, we can explain it more using the diagram. Here we have the rule written in the knowledge base contains meat. If ingredient X meat and underscore, which is ignored, and at the same time, this is the second condition, the meat should be, or the meat. Okay, so meat, this is the first predicate. We have a call for the ingredient X meat, and the ingredient might be tagine or it might be stew, and the tagine meat and the meat um, might be aubergine, because this is the variable, might be aubergine or it might be tomato. And of course this will return, the call for this one will return fail, and the call from this one will return fail as well. So it will creep, or it will recall the ingredient to go to the second track, the second option, which is ingredients 2. Ingredients 2, yes, we have the meat, which might be beef or it might be potato, and this one is going to return true. uh, that's why the the final result would equal to stew. But this one, if we're going to continue and press semicolon, this one will return false. So we have only x equal to stew. Why this one is going to return false? Because meat, it doesn't have potato. The predicate meat, which have been defined in the knowledge base, doesn't have potato. Okay, to get out of the trace command, uh, we just type no trace and full stop, then press enter. So we to get out of the debug mode, so we just type also no debug dot and press enter. Let's do the second type of debugging, which is um, as we explained before, through the graphical debugger. So we're gonna click on debug, and instead of typing the trace command, we're gonna go for the debug, then select graphical debugger, and start type trace, then dot and press enter. Okay, let's type the command. And dot and press enter. Okay, this is how it works now. As you can see, it opened the graphical debugger here. Okay, we can go through the steps step by step by clicking that button, which is called the skip over this goal. Uh, okay, so this is the second call for the ingredient. Then we press again. We go for the third call for the meat. Then we press again. It's gonna return. Okay, and this is the redo. Then when we press again, this is a new call for this. Here, as you can see, this is the value of X, tagine, and the meat is tomato. Then we click again. Now that means this is fail. And when we press again that button, we made another recall for the ingredient. And the meat here is gonna equal to beef, and the X is gonna equal to stew. And when we press again, okay, that's it. That means we finished, and the result x is equal to 2. Recursion. Recursion in Prolog is similar to the one we did in imperative language before. So it's a kind of, in imperative we said that it's a kind of calling a function that calls itself. And this is the same idea here in Prolog. So consider that A is the parent of B. That means A is the ancestor of B. So A is ancestor of B if A is parent of B. And the same idea here, if we have someone in between A and B. So, okay, if A is the parent of X and X is the ancestor of B, that means, of course, A is the ancestor of B. So let's consider this task to be familiar with the recursion in the Prolog. Here we have you remember the factorial n that we did in the imperative programming language. We're going to do the same in the Prolog, the factorial n. So factorial 0, comma 1, that means this is the base case. We have to start with the base case, and it means that 1 is equal to factorial 0. When we go down here, this is factorial n result. That means the result is equal to factorial n. If n minus 1 is equal to m. That means if we assign the value of n minus 1 to m, and the part result is equal to m, which is already n minus 1, and at the same time result is equal to n multiplied by part result, which is already equal to m, which is n minus 1. Okay, let's do this using the SWI. So let's create a new knowledge base by click on the file, then new, then name it factorial, and save. Okay, here we can type the same commands that we already see. The knowledge base rules. This is the base case, and this is the general case. And after calling the general case, it should end up with the base case. Okay, why it puts here underline? Because this is a kind of recall to the same function again. Okay, let's save this entry of data. Let's save this one, save the buffer, and let's go for the SWI environment and consult that file, factorial. Let's run the query to see if it will give us the correct answer or not. So if we run factorial 5, comma, answer, and we press enter, what do you expect the result? The result is going to be 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, which should be 120. So let's press enter and see the answer, and that was correct. Let's talk about the lists in Prolog. A list in Prolog is an ordered collection of items. So suppose that we created the list to contain the 3 colors red, green, and blue. So the first one is going to be considered item number 1. Green is going to be considered item number 2, and blue is number 3. 2 things to say about the list. It should be in order. This is number 1. Number 2, the first item in the list is all the time considered the head, and the rest is going to be considered the tail. So the list in Prolog consists of 2 parts, head and tail. The first item is the head, and the rest of the items is going to be considered the tail. And this is how we consider it. H is for the head, and T is for the tail. Let's create this list in Prolog to see how does it work, and then we query it to see what would be the result if we wrote H and T. Okay, so number one, we open the SWI, then we create new file knowledge base to have the list inside it, but we already have this one here. This is my list, so I'm going to open it to see what had been written. This is my list, bracket, square bracket, red comma, green comma, blue, and square bracket, bracket, and full stop. Okay, let's consult this file. So when we run the query, it will be operated on that file, my list. And then let's type my list, bracket, square bracket, H, then the vertical bar from the keyboard, then the tail, then close the square bracket, then the bracket, then dot, and press enter. So the result was H is equal to red, so this is the head, and the rest is going to be considered the new list called T, which is the tail. Okay, list operations. Let's see some of the operations that can be done on the list in Prolog. Suppose that we have to join two lists together to create a new list. This operation is called append. So what we're going to do here is write down the append command and bracket, then square bracket, then the first list of items like A, comma, B, and this is the first list, and write down the second list of items, square bracket, okay, C, comma, D. So we have two lists now to append or to merge together to put them in a new list. Then, comma, the name of the new list. Let's say we're gonna call it my list, or let's say new list, new list. So what do you expect would be the components of the new list? Would be the items of the new list. Okay, yes, it would be A, B, C, D. So let's close this one and for the full stop, then press enter. So the new list now contains the first two lists. Okay, let's do another example here. Suppose we're gonna say append, then bracket, then a name of a list like list 1. Okay, comma, and let's do here a list with some items C, comma, D. Okay, then we write the list items of the full list. So A, comma, B, comma, C, comma, D, and include this list. If we press enter, what do you expect would be the result? The result is to extract the first list from the complete list, because this is the second list, this is the first list. If we combine them together, that means if we append them together, that means we are going to have the full list A, B, C, D. So because the second list is C, D, so the first list should equal to A and B here. And let's press enter. So the first list is going to equal to A and B. Okay, let's see another built-in predicate, which is called the member. And this predicate will exactly look for one of the items you provided, if it exists in a list or not. Like here, member, member C, and the list. So if C is member of that list, yes, to return it. If it's not, to return a false. But if we provided here X, like a variable, so what would be the result? The result is equal to, might be A, it might be B, it might be C or D. That's why X might be equal to all of this. I'm gonna leave you the chance. To do it practically on SWI.
Okay, let's know how to read and write in Prolog. We're going to use the predicates write and read. These are built-in predicates. So if we want to display a message or to display the content of a variable on the screen, we just use the keyword right, or the predicate right, and followed by the parentheses and the double quotes, and inside it we write the text or parentheses and the variable. So let's examine this using the SWI. Let's write and hello world, and then we close it, then dot and press enter. Okay. How to read the sequence of characters from the input keyboard. We just use the read predicate, and we open the parentheses and write a variable to receive the input from the user. Let's say name, and then we close the bracket and dot and press enter. The user should write the input now, like his name, and press full stop and press enter. That means the name now contains Mahmoud.